Okay, so today's lesson is on slope fields. So you should all have the handout like this that you've downloaded off of SaintsNet. Yours is blank, mine's filled in with the key. The key though will be going to be posted on SaintsNet. So slope fields, and I just realized I didn't bring my calculus book with me, but I have one over here. I left my calculus book at home. Just to give you a real quick eyeball of what a slope field looks like. Your book does have some in chapter 9, section 2. So let me real quick turn to a couple of slope field examples so you can see what they're going to look like. So these are slope fields right here. So I'm on page 594 and 595 in your books, 593. So this is a slope field, okay? See these? If you want to open your book, you can maybe see a little better. This would be a slope field. And basically, each little tick mark represents the slope at that coordinate. So it's like you went coordinate by coordinate and drew a little line to represent the slope. Is it a negative slope? Is it a positive slope? Is it a horizontal slope, a vertical slope, which will be, an undefined slope, and then once the field is created, the idea is that if they said, okay, draw me a curve in this slope field that goes through, what would they do? 0, I'm reading upside down here, 0, 1, you're going to take that point and follow the natural path of the slope field to create your curve. And so if we turn the page, there's another one over here. So we've got this slope field that we've created with all the slopes at all the individual coordinates. And then as we go through, they went through the origin for this one. So we go through the origin and we follow the natural path of the slope. We create this S-curve, and it varies depending on which point they ask us to draw it through. This topic, there's no exact perfect curve they're going to look for. What they're going to look for you is the ability to go point by point and draw a little estimated slope line. Well, you may say, well, how are they going to know the difference between a slope of 2 and a slope of 3? They're not. What they're going to look for is that all your positive slopes are facing the right way, all your negative, your slopes of 0 or horizontal, your slopes undefined or vertical, and and that your slopes that are getting steeper look like you're making the attempt to make them steeper. And then that your curve is doing its best to follow the flow of the slope field. So we're going to start with example 1 on the first page of your handout. dy dx equals x plus 1. Well, according to this slope equation, that means that at each x, my slope is going to change. Will y in any way affect this slope field? No, the y won't, because there's no y in the derivative function. So when x is 0, my slope is 1. So when x is 0, I'm going to draw a slope of 1. And that would be for any x's that are 0. Well, x is 0 anywhere on the vertical axis. So I'm going to go ahead and draw a slope of 1 on my y-axis. Then when x is 1, what's my slope? Well, when x is 1, my slope is 2. So when x is 1, my slopes get a little bit steeper. When x is 2, my slopes are 3, so I'm getting steeper. I'm doing my best. I probably started a little bit too steep to begin with. And then what happens when we go on the left side? Well, when x is negative 1, what's my slope? When x is negative 1, my slope is 0. So all of these should be horizontal little lines. And then when x is negative 2, what's my slope? It becomes negative 1. And then finally, when x is negative 3, negative 2 gets a little steeper in the negative direction. So what they're going to look for is that you've got your negative slopes in the right spot, your positive slopes in the right spot, your zeros in the right spot, and that you've done your best to try to show steepness. So if you look at my example, that's what my slope field looks like. So let's go over and do the second one. dy dx equals 2y. What's going to affect all these slopes? This time all the slopes are affected by y only. So x has no effect on the slope. So, when y is 0, well, y is 0 anywhere on this x-axis. When y is 0, what's the slope going to be? 0. So, all of these slopes should be little horizontal lines. Then, when y is 1, what will all the slopes be? 2. So, all of these slopes are going to be slopes that are positive with a positive 2. And when y is 2, what's the slope? 4. So, they're getting even steeper. Again, x has no effect on these slopes. When y is negative 1, what's the slope? Well, when y is negative 1, now the slopes are negative 2. And when y is negative 2, we get negative 4, so it's steeper in the negative direction. Best we can do. And so what's going to happen is they might say, okay, draw for me now a curve that goes through 0, 1. And so I'm going to do my best to estimate, well, these, if I kept going, these are just going to get steeper and steeper. So this appears to be growing like that. But as I come here, what's this? It's almost like a horizontal what? Asymptote. And so that would be the curve that results from this. It's actually, if we were to actually do the antiderivative of this, we would have to do separation of variables. So we would end up with 1 over y dy equals 2 dx. That gives me, integrate both sides, natural log of y equals 2x plus c. And if I wanted to go through 0, 1, then when x is 0, y is 1. Natural log of 1 is 0, so c disappears. And so then we get e to the 2x equals the absolute value of y. E to the 2x, well, what do we know e to the x looks like? That curve right there. E to the 2x, when x is 1, is going to be, I'm graphing e squared. When x is 2, e to the 4th, and so forth. But I end up with the e to the x curve, basically. So this is what happened. Now, you're not going to do this for the slope field problems, or you're making the problem way harder than you need to. You're going to do your best fit curve. So let's look at example 3, and then 4, 5, and 6 I'm going to leave for you to do on your own time. The keys on SageNet, you'll be able to check it with my key, and then we're going to go to the next page. So number 3, we have dy dx equals x plus y. Now this time, who affects the slope? Both coordinates do. So we have to think about both coordinates. So you might want to make an XY chart. I don't know what works best for you. For me, I just go point by point. Here, the point is 0, 0. So when x is 0, y is 0, the slope is 0. So horizontal line. Here, x is 1, y is 0. So 1 plus 0 is slope of 1. Here, x is 2, y is 0, so I'm getting steeper. 3 plus 0 is a little bit steeper. Over here, x is negative 1, y is 0, so I get negative 1. Then I get negative 2. Then I get negative 3. Then we move up. So x is 0, y is 1. 0 plus 1 is 1. Then over here we get 1, 1. 1 plus 1 is 2, a little steeper. Then we have 2 1s, so we get 3, and then we get 4. Over here we have negative 1, 1. Well, what's negative 1 plus 1? A slope of 0, so we end up with a slope of 0 here. Here I have negative 2 1s, so negative 2 plus 1 gives me negative 1. And here I have negative 3 plus 1, so a little steeper. And then we keep going from here. We've got x is 0, but y is 2. So 0 plus 2 is a little steeper. Over here we have negative 1 plus 2. So we have 1, so not as steep. Over here we have negative 2 plus 2. So that gives me 0. And then over here, we end up having a negative 1. And what do we notice is happening? All the zeros are on a diagonal, so I can go ahead and fill in my zeros. And then we may notice other patterns. If not, you can just go point by point. So here, x is 0, y is negative 1. 0 minus 1 is negative 1. But I sort of see a diagonal. Weren't those all negative 1? And weren't these from here? Let's see. Right here, x is 2, y is negative 1, 2 plus negative 1 is 1. So we see a diagonal of positive 1s up this way. You with me? and these are all slope of 2, and so forth. So we could start to see a little pattern here, but if not, you can plug in all the points. This is just getting steeper and steeper. Over here we've got -1, -1, that makes -2, so it's a little steeper. -2, -1 makes -3, getting steeper. And so forth. So you would fill out your entire slope field. So I'd like you to finish 4, 5, and 6 when you turn this video off, and you can check them right there on SaintsNet. So that's one thing you're going to be asked to do. Go to page 2, okay? On page 2, what we're looking at are slope fields. We are supposed to match the slope field with the curve that it could represent fitting on that field. Remember how this curve is e to the x. It fits on the slope field to y because it follows that pattern. So for example, I think the easiest thing to do is start with number 7 at the bottom, y equals 1. What do we know y equals 1 makes? It makes a horizontal line. Which slope field would a horizontal line naturally fit on? Letter D, so 7 is letter D. Let's do 8 together. 8 is the line y equals x. So we're looking at a line that has a slope of rise over run 1 that goes through the origin. Which slope field could have a line going through the origin with a slope of 1? H, good. H. Number 9. Y equals x squared. Well, what do we know y equals x squared makes? A parabola. So which slope field would a parabola fit on? Well, it's not A, it's not B. B goes up and down. We've already used D and H. F does some funky looking curve. E goes up and down like B. C goes down. That leaves me with, not C. G goes down. C has steeper slopes to a 0 slope, back to steeper slopes. So C would go to letter number 9. So let me give you a chance right now to finish 10, 11, 12, 13, 14. Look and see, and then I'll give you the answers. Okay, actually what you should do, pause your video if you haven't figured them out. Pause your video and then start it back up when you're ready to check. I'm going to go ahead and give you the answers. So 7 is D, 8 is H, 9 is C, 10 is F, 11 is A, 12 is E, 13 is B, 14 is G. If you have questions about this, send me an email and I'll talk to you during office hours. This afternoon we can do a Google Meet. Okay, so now we're on the last page of the handout. Now we're looking at slope fields and we're matching them with their dy dx equation. We're not matching them to the curve that fits. We're matching them to which slope field would be created by that dy dx. So number 15, dy dx equals 1/2 x plus 1. Well, dy dx is only affected by x. So I'm looking for one where the y's, changing the y doesn't change the slope. So I look at A, as I move up and down my y values, my slope is changing. When I look at B, as I move up the y-axis, what are those slopes doing? Or when x is 1, as I move up, when x is 1, they don't change. So it might be B. C, as I move up and down the y-axis, those slopes change. The ones above the x-axis are negative, the ones below are positive. So it can't be C, and it can't be D. Same thing happens. The slopes as I move up and down the y-axis change. So that leaves me with B. Another way to approach that is to plug in values. Plug in when x is 0, you get 3/2. When x is, I think -2 is a really good one to plug in, because then you would get -1 plus 1. I need a slope of 0. So when x is -2, which one of these has a slope of 0? Well, it's not A. When x is -2, it's not A. Or if I come over B, it is B. So you want to figure out which slope field goes with which differential equation. We've already done 15 is B. So let me get, again, pause your video. See if you can get 17, 16, and 18. I'm going to go ahead and give you the answers. Please stop your video till you've answered these and then start it back up. The answers are number 16 matches with D. Number 16 matches with D. Number 17 matches with C. And number 18 matches with A. Now, what I've seen on AP exams, I've seen like page 1 a lot, where you create a slope field. We really like those. And then I've seen like 15 through 18, where they give you one slope field, and then they give you 4 dy dx's or 5 dy dx's along the bottom, and you have to figure out which one makes that slope field. And a lot of times the easy thing to do, get yourself an XY chart going and test different X and Y's, and if the slope, if you put them in the dy dx equation and it doesn't give you the slope on that slope field, take it out of the running and try a different one. Okay, so last one, 19, wants you to sketch a curve that fits the slope field through each of those points. When you check my key online, I've got a bunch of work I was doing on the right hand side. Ignore that. All you have to do is do your best sketch curves for 19 and 20. So all you need to do is look at my curves on the key when you check that. If you have questions, again, I suggest you get this done early before office hours so you can send me an email to say, hey, I'm not getting this. Because this is really usually a pretty easy, it's not usually worth more than like 1 or 2 points in the AP exam, but most people usually get that point or two. So if you're not, write me so I can do a Google Meet with you during office hours today. Okay, doke.